More examples. We have in a factorized, it says there, we have a. So if we expand this first, we have 2 raised to n plus 3 plus 2 raised to n. That is also equal to 2 raised to n multiplied by 2 raised to 3 plus 2 raised to n. Because this one, we have a law that says that if we multiply the bases, we need to add the exponents. So we added the exponents, so we need to expand it and multiply the bases and separate the exponents. As you can see, we have a common factor, that is 2n, 2 raised to n. Then we have what is remain here, 2 raised to 3 plus 1. And then we have 2 raised to n. We have 2 raised to 3 is 8 plus 1. Then we have 9 multiplied by 2 raised to n. This will become 9. Okay, B. We do the same. We have 2 raised to n plus 2 raised to 3. But 8 is also 2 raised to 3. So we have, simplify, common factor. Sorry for that. This I missed. That should be multiplied by. The same as we did in A. So the common factor is 2 raised to 3 or 8. You can use 8 or you can use 2 raised to 3. I will use 2 raised to 3. And then we have what remains, 2 raised to n plus 1. What remains here is 1 because there is 1 times there. Then we have 8 multiplied by 2 raised to n plus 1. Okay. Next, we have 2 raised to 3n is the same as 2 raised to 2n multiplied by 2 raised to n. That is also 3n. Okay, if you cannot see that, maybe I will do another way. We have 2 raised to 2n plus n. That is also 3n. Then we have plus 2 raised to 2n. If we expand this, we have 2 raised to 2n multiplied by 2 raised to n plus 2 raised to 2n. Then we have a common factor. We factorize it. So we have 2 raised to 2n. That is the common factor. What remains is 2 raised to n plus 1. So we have already factorized it. More factorization for A. We have 4 raised to x minus 9. As you can see already, maybe this is now a difference of 2 squares, but we need to show that they are really difference of 2 squares. So 4 is the same as 2 raised to 2 raised to x minus 9 is 3 raised to 2. If we change the places, or we can use this, we can do this way. 2 raised to 2x minus 3 raised to 2, and then we have 2 raised to x raised to 2. Changing the places, it's the same. Minus 3 raised to 2. Now we see that we have 2 squares. And we need to the difference of 2 squares. Sum and difference of binomial, sorry. Sum and difference should be plus and minus. Yes, so just take the square root of both terms. Then we have this is 2 raised to x plus 3, and then 2 raised to x minus 3. That's it. And this one, I guess this is a perfect binomial, trinomial. Then it should be the square of a binomial. It should be. How? Let's see. if we do this, 3 raised to 2 raised to x plus 4. Sorry, 4 should be expressed in 2 times 2. And then we have times 3 raised to x plus 2 raised to 2. Changing the position, like what we did here, this one, we just changed the position, so we have 3 raised to x raised to 2 plus 2 times 2 times 3x plus 2 raised to 2. So we can see now the factor of this is 3x plus 2, and then we have 3x, 3 raised to x, it should be 3 raised to x plus 2, and a square of a binomial, 3 raised to x plus 2 raised to 2. Why? Because it says here, square of binomial a plus b squared, parenthesis squared is a squared plus 2ab, or plus 2ba, it doesn't matter, plus b squared. Okay, so the factor should be this one. Okay, did I find a squared? Yeah, there is my a squared. Did I find 2 times b times a, or 2 times a times b? So 2 of b squared first. Did I find b squared? Yes, there is my b. This is my b squared. This is my a squared. This is my 2. This is my b. This one. Or this is my a. So 2ba. That means this is squared. Okay. In my next video, then we will be discussing this example, and I think I have one more example after this, so stay tuned.